Okay, so because we are now dealing with two different types of graphs, you always need to first check your units and make sure that you are in the right mindset. This one here is a distance time graph. So this object is not moving, it's sitting 5 meters from the origin. So on a distance time graph, this would not be moving. All right, so moving on to speed time graphs. Again, make sure you check your unit because there's a big difference between speed time graphs and distance time graphs. This one, you'll notice that the line is going upwards. This y-axis is the speed, which is meters per second. So this one is actually increasing in speed or accelerating. Okay, so oops, I guess I'm doing one on top of the other. That disappeared. Okay, so this one is increasing in speed. Here we go. Give me 1 second here. Okay, so this is increasing in speed. Why? Because the y-axis here is speed. So we could think of this as like 0 meters per second, 5 meters per second, 10 meters per second. Or if you're more familiar with miles per hour, I could call it miles per hour. 0 miles per hour, 5 miles per hour, 10 miles per hour. So as the line goes up, it's increasing its speed, which looks on a distance time graph would look like this. This is a distance time graph that is increasing in speed. The reason we had the equal sign here is these two graphs are showing the same thing. So on a speed time graph, a straight line going up represents an increase in speed or an acceleration. On a distance time graph, a curved line going up. Okay. Also, the unit for speed is meters. The unit for acceleration is meters per second squared. Why? Well, because we have a meter and we have a second. So the way you write it is like this: meters per second squared. So anytime we're talking about something accelerating, like this object right here is accelerating, we would say meters per second squared. What that means is that each second it gets that much faster. So for example, if I say 3 meters per second squared, what that means is it's traveling 3 meters per second at the first second, 6 meters per second, 9 meters per second, 12 meters per second, 15 meters per second. In other words, it's getting faster by 3 meters per second each second. Okay, moving on. Next graph. Okay, this one. Okay, so the next graph. Here we have another speed time graph. This here is showing an object moving at a constant speed. The reason this is a constant speed is because it is staying right at, let's say, 10 meters per second. So again, remember that on these graphs, the y-axis on a speed time graph, this is speed again, not distance. So on a speed time graph, this y-axis is the speed. What's going on here is it's staying at the same speed, that speed being 10 meters per second. Whereas the distance time graph, the y-axis is meters. So what's going on here? Well, it's traveling the same distance at the same amount of time. So in other words, this graph here is showing the exact same as this graph here. They are both moving at a constant speed, and that's why I had an equal sign there, because remember, they're equal. And again, always check your units before you start, because now there is no just distance time. We're also looking at speed and time. Okay, here's the next one. Everybody draw that graph. And let's talk about what it's doing. So everybody draw that graph in their science spiral. You will need this. Didn't I give you a pencil yesterday? right, guys, y'all need to draw these graphs because you get to use them on your assignment day. If you don't have these graphs, you can't use it on your assignment. Okay, so this is a speed time graph. Again, because we're now working with multiple things, I'm always going to check my units first. So, Miley, can you describe the motion of that object? What's it doing? What's that object doing? Speeding up, slowing down, traveling at the same speed? What do you think it's doing? And again, this is speed, so a little bit different than distance. Okay, well, it is speed, right? You're thinking of distance. On a distance time graph, a straight line is constant. However, is this change in speed? Let me put it like this. If this was 15, 10, 5, 0 miles per hour, is it changing speed? Yes. So, again, faster or slower? Slower. Very good. Yes. So what's going on here is that this object is slowing down. Okay, remember that's speed. So this object here is slowing down. Why? Well, because the line is going down. And again, we're talking about speed. We're not talking about distance. Okay. So let's draw, what does a distance time graph look like? Slowing down. Let's draw it. Okay, so here's distance and time. Let's draw a distance time graph slowing down, and here it goes. Starts off fast and gets slower and slower and slower and slower. In other words, this graph is the same thing, is equal to that graph. It's just this is speed and time getting slower, and this is distance and time getting slower. All right? So this is a distance time graph of an object getting slower. All right. So, again, these are the same thing. That's why there's an equal sign. They're showing the same motion. All right, next one. It says draw a speed time graph that shows an object not moving. All right, so let's draw a speed time graph of an object that's not moving. And there's really only one way to do this on a speed time graph. I can do it multiple ways on a distance time graph. So here's my graph. If this is speed, and this down here is time, how would you draw a speed time graph of an object not moving? All right. Let's think about that. Well, this y-axis here is speed. So in other words, we have 0, 1, 2, 3, let's say miles per hour. Okay, in science, so we use meters per second, but I'll say miles per hour. If I was going to draw something not moving at 0 miles per hour, how would I do that? Well, I would have to do this. I'd have to put a line right at, oops. I would have to put a line right at 0. Okay, so how fast is it traveling? It's traveling 0 meters per second. Okay, well, how can I draw the exact same thing on a distance time graph? And I'll tell you, it's really not the exact same thing, because the reason you would use different graphs is to really show different types of motion, but it's an equivalent, I guess I could say. So how could I draw something very similar on a distance time graph? I would draw it like this. This being my distance is in meters, and then this being my time. How would I draw a graph of an object not moving? Well, I could do this. Is that not moving? Yeah, because why? Well, if that's 5 meters, again, let's say your mailbox is 5 meters in front of your house, you go sit in front of your mailbox. There you are, sitting in front of your mailbox. Could I also draw it like this? Is that object not moving? Yeah, that object's not moving. It's sitting at 2 meters. Okay? I could also draw it like this. Oops. This is distance time, by the way, versus this is speed time, very different. So on a distance time graph, is that not moving? Yep, that's you sitting at home. So sitting at home, sitting in front of the mailbox, sitting on your front patio. Okay, all 3 of those are not moving on a distance time graph. Whereas a speed time graph, it has to be at the 0 line. Okay, because the only way you're not going to be moving with speed is if your speed is 0. Okay, so in other words, all 3 of those graphs are distance time. All 3 of those graphs are the same as that speed graph, where it's at 0. Okay? Okay, so there is an assignment in Schoology. You can use your notes that you just took. I think where I'm going here. There's an assignment in Schoology under Tuesday. Do it now. Don't log off and say, oh, I'll do it tonight, because it won't get done. Next thing you know, you'll have 0. Okay? So let's go ahead and get that started. I'll be here if you have any questions. Yes. With the assignment? Okay.
Mr. Leonard, I don't get the last question.
What's the last question?
It's like the meter and time of meter and seconds. Like, I don't know if I'm gonna like do speed matching to the distance, or I'm not sure how.
The last set of questions?
Yes, sir.
That's when I have a distance time and a speed time graph, I believe. Go see what it is.
Okay.
Is the assignment called matching graphs?
Yeah, matching graphs. That's what we're working on. So the last set of questions that look. Yeah, I think if this is what you're looking at, this is where your notes come in to be important. Is this what you're looking at?
Yes, sir.
Okay. Well, on the left-hand side, we have meters per second. On the right-hand side, we have meters per second time. This is actually speed. So this is a distance time graph. This is a speed time graph. So for example, what's this? If this is distance time, what's it doing?
At a constant speed.
Okay. And out of this one, which one's moving at constant speed? It's actually going to be this one, right?
The first one.
Yeah, the first one. Yep.
Okay. Thank you.
You're welcome. All right. Josmar, are you there?
Yeah.
I don't think I've gotten any. Let me go look at your grade. I don't think I've gotten any work or much work from you in the last few weeks. Yeah, I haven't got, Josmar, I haven't got any work from you this 9 weeks, and almost last 3 or 4 weeks. Were you aware of that?
Huh?
Were you aware that you haven't turned in any science work? Because I know you're in class almost every day. I'm sorry?
Oh.
All right. There's a simple machine lab you need to do. Why don't you try to get today's assignment done? There's a simple machine lab. I sent you an email last Friday, I think it was. Why don't you try to go through and get some of those assignments done, okay? All right. Austin, are you there?
Bye. Have a nice day.
Take care. Austin, are you there?
Yes, sir. I'm here.
All right. I think it's kind of the same thing with you, Austin. I haven't got any work from you this 6 weeks. Can you go get some work done?
Yes, sir.
All right. Just do today's work. Go do that lab. I sent you an email last week. That lab is a test grade. And then from there, just kind of go folder to folder and see what you can get turned in. Okay?
Okay.
All right. Thank you.
Mr. Leonard, I don't get the last question.
You're matching the distance time graphs to the speed time graphs. So you're talking about the last set of questions?
Yeah.
Yeah, so the ones on the left, let me go see if I can open it.
Bye. See you tomorrow.
All right, take care. All right, so the ones on the left are distance time graphs. The ones on the right are speed time graphs, meters per second. So what you do is you would match the graph, the distance time graph to the corresponding speed time graph.
Oh, okay. Thank you.
And it's pretty much very similar to number 3, except I just changed the units.
Mr. Leonard,
Yes.
I don't get number 2.
Let me get over there. I'm trying to find my way back. You mean second set of graphs?
Yes, sir.
Okay, well, those are speed time graphs, so you just match the speed to the graph. So looking at graph number 1, see that flat line?
Yes, sir.
So what type of speed is that showing?
Constant.
Very good, constant speed. So you would match that to the constant speed. And then number 2 is showing what? Speeding up, slowing down, same speed?
Slowing down.
Yep, slowing down. So you would match that to slowing down. So you're halfway there.